So this is section 4.2, and this is dealing with Pascal's triangle instead of using regular polynomial expressions, multiplication, whatever. This is a different method. The reason that this method exists is strictly because I don't want to solve something like this by hand. Because what this means is that I'm going to have to take x plus y times x plus y times x plus y times x plus y times x plus y. Right now I'm going to have to double distribute this, get an answer, and then put this on there, and then put this on there, and then put this on there. And that's a lot of work. That's something that I really don't want to have to do. So that being said, Pascal's triangle was created, or not created, Pascal's triangle exists. And someone realized that the relationship that this triangle has a relationship to what's going on here. So one thing that you just check for Pascal's triangle is this thing right here tells you what number of row to look at. So this tells you what number of row to look at. Now, one important thing about Pascal's triangle, and this is going to be where people get stuck, this thing right here is row 0, this is row 1, this is row 2, row 3, row 4, row 5, and so on. A lot of these numbers come from the powers of 11. So if you take 11 to the 0 power, that's 1. If you take 11 to the first power, that's 11. If you take 11 to the second power, that's 121, so on and so forth. That's where these numbers come from. That's why 0 and 0, 1 and 1, so on and so forth. All right? So that being said, what we're going to deal with is we are going to deal with the triangle to help us solve this problem. So if I look at this, I can see that I'm dealing in row 5, so I'm going to go to row 5, and I'm going to write down all of these as coefficients. So 1, 5, 10, 10, and then I'm going to come down, hang on. I want to try to make this a little bit easier to look at. So I have, again, row 0, row 0, row 1, 2, 3, 4, and 5. So this is the row that I want to deal with because that's the power on my polynomial. And instead of multiplying this out, which that is always an option, this is just more time saving, I'm going to write down my coefficients. Now these coefficients are just what I see right here. So I'm going to write down 1, 5, 10, 10, 5, 1, and I'm going to leave some space. So I've got 1, 5, 10, 10, 5, 1. So I'm leaving a little bit of space here. So this is basically saying that all of these terms are going to be given by whatever row this is on the polynomial. So I'm going to put plus signs right in front of all of these numbers. And that takes care of all the coefficients. So now what I'm going to do is I'm going to look in here for what the actual terms are. So the first thing I'm going to do is I'm going to put an X next to all of these coefficients. And then I'm going to put a Y next to all of these coefficients. And now the thing that's going to happen is I can basically finish off this entire problem by looking at this power. For the x's, I'm going to write them in descending power. So 5, 4, 3, 2, 1, 0. And then for y's, I'm going to write them in ascending order. So 0, 1, 2, 3, 4, 5. So that being said, I can now simplify this entire thing, and then I'm done. Y to the 0 power is just 1, so it goes away. So my first term is going to be x to the 5th. Plus, this can't simplify, so 5x to the 4th y. The next one can't simplify, so 10x to the 3rd y squared. The next one can't simplify, so x squared y to the 3rd. And then I get 5xy to the 4th. And I get 1x to the 0 is 1, and y to the 5th, which is just y to the 5th. Now, that being said, look how much work I did. I wrote down basically one row, and then I got my final answer. This is why Pascal's triangle is really, really nice. This is why something that as you deal with this, and if you work with it a little bit, it becomes very, very nice. But the only reason it's not super nice is because Pascal's triangle only works when I have a set of parentheses with a number and another number, so plus or minus another number, raised to some power. And I'm going to rewrite this so that it doesn't look like x and x. I have a number or something plus or minus another number raised to a certain power. That's the only way that this works. So this is taking a binomial and raising it to a power. That's the only time that Pascal's triangle ever works. So this is just something that as you work your way through this, you can realize that there might be an important part of this. There might not be an important part of this. This might be something that you think is important. This might be something that you think is a big deal because it's an SAT related type question. But for our purposes, it's not really going to be that big of a deal because there is only one time that we can use this. That's it. And that one time that we can use it is like this. Now, to be completely honest with you, this gets to be a very, very ugly process when we get down into like row 7, row 8, row 9, because look at how long these things are. Like this thing gets to be a very, very long process when we start to have high numbers like that. So the only problems that I would ever give you are like problems to the third or to the fourth, and most of you would just prefer to multiply it out anyway. So this is, again, something that's SAT type related, all right? So the way that they might ask you a question is they might ask you a question that looks something like this. So the SAT might ask something like this, where they'll say like, given x plus y to the 6th, what is the coefficient on the x, y to the 5th term? So they might ask you something like this, like what's the coefficient on the x, y to the 5th term? And if we look at this, this tells us what row we're dealing with. So this tells us the row. So 0, 1, 2, 3, 4, 5, 6. And if I look at this specific row right here, 1, 6, 15, 20, 15, 6, 1. If I look at this, I would, if I don't know how to use Pascal's triangle, my only option right here is to multiply this up. And I don't want to do that. But if I look, I can go through and I can say, all right, I know that this right here is going to be x to the 6th, y to the 0. This is going to be x to the 5th, y to the 1st, x to the 4th, y squared, x to the 3rd, y to the 3rd, x squared, y to the 4th, and then x, y to the 5th. And I can see, oh, that's what they're asking me right there, right? That's what they're asking. What's the coefficient in front of that? And the coefficient is just 6. So this is just something that it creates a problem that can be solved very efficiently and very quickly if you know the steps to do it. If you don't know the steps to do this, this could create a very, very long problem and a very big issue that you would have to multiply a whole bunch of stuff out, and that would be a big challenge. All right. So that being said, this is what Pascal's triangle is. The steps to Pascal's triangle, if you want to write them down or want to know what they are, you find the nth row. So you find whatever the nth row is. That's step 1. Step 2 is you write those coefficients. Oops, slow down. So you write those coefficients down. Then the next step is you write, I guess we will call it like the first variable. In descending degree. So you write your first variable in your descending degree, and then you write the second variable. My kids keep dropping stuff downstairs. In ascending order. So that's how you're going to work through these problems. And to be completely honest with you, I am never going to ask you to do this. I'm not going to ask you to do it on a test, and I'm not going to ask you to do it on a quiz. I'm going to ask you how to multiply things out by hand, and I'm going to ask you how to multiply things out using like polynomial, binomial expressions. I'm not going to ask you to do this. All right? Because one, it's very time consuming sometimes. And number two, it's just something that could be very, very challenging. Now, that being said, hopefully this is something that if you see it on the SAT now, you can look at it and say, oh, I at least have a fighting chance with this. I'm not saying you're going to remember it because I'm not requiring you to practice it, because in complete honesty for our class, it's kind of a waste of time, especially when time is of the essence right now. But hopefully in the future, you can look at it and say, oh, yep, I know how to do this, or at least know how to try to do this. Does anyone have any questions or any issues or anything that you would like to talk about this at all?
So like if we get a question like this on the PSAT or the SAT, it'll give us like that whole triangle thing.
I I think so. I think it will. But the thing with the triangle is it's really, really easy to create yourself. So it starts out with a one on top and a one on the sides. And then the only thing that happens is the two numbers in the middle get added together. So there's always a one on the outside, but then one plus one gives me two, and then a one on the outside. There's a one on the outside, one plus two gives me three, two plus one gives me three, one on the outside. One on the outside, one plus three is four, three plus three is six, three plus one is four, and then one. So it just keeps getting repeated over and over again. So they might give it to you, they might not. I'm honestly not sure. It depends on the type of question. Any other questions? All right. Let me stop recording.